In this video, we're going to prove the formula for the distance from a point to a line in R2. Okay, so in our diagram is the line AX plus BY plus C is equal to 0. That's the line that goes down to the right on your screen. And we've also got the point AX. So here's the line AX plus BY plus C equals 0. We've got the point P with the coordinates x naught, y naught, which is not on the line. And that point is a particular distance d away from the line. And the distance that we're interested in is that perpendicular distance. Now, since the line has the Cartesian equation ax plus by plus c, and we're in 2 dimensions, therefore the normal vector of the line is AB. Now, let's consider the point on the line P1, which will give the coordinates x1, y1. It's on the line ax plus by plus c is equal to 0. And we can obviously tell, therefore, that the vector p naught p1 will have the components x1 minus x naught, comma, y1 minus y naught. Okay, and well, there it is right there. And again, the normal vector to the line is AB. And notice how that normal vector is collinear with the line along which that shortest distance lies. Okay, now the angle between P1, P naught P1, the vector, and the normal vector is given by theta. And we're going to indicate the point R to be the point on the line, which represents the shortest distance from P naught to the line. Okay. Now, we know that P naught P1 dotted with the normal vector is the magnitude of P naught P1 times the magnitude of the normal vector times the cosine of theta. And if we were to, that's just by the definition right here. That's just by the definition of dot product. Now, if we're going to divide both sides by the magnitude of the normal vector, then here the magnitude of the normal vector will cancel out, and we'll be left with the magnitude of the vector P naught P1 times cos theta equaling P naught P1 dotted with the normal vector over the magnitude of the normal vector. Okay? So there's that written that way. Now, from this triangle that we formed in our diagram right here, well, draw a little bit better. From that diagram, we know that the cosine of theta is actually equal to the distance that we're looking for, the adjacent side of that, all over the hypotenuse. So the adjacent side of that is equal to the magnitude of P naught r. This is the magnitude of P naught r. And the hypotenuse is equal to the magnitude of the vector P naught P1. So since we know this formula, as stated earlier, and since we've just established that this cos theta here is equal to P naught r, the magnitude of P naught r over the magnitude of P naught P1, we can sub the magnitude of P naught r over the magnitude of P naught P1 in for that, and that'll give us this equation right here. Okay. Now, what happens then is we can cross out these two, and we get that the magnitude of P naught r is equal to P naught P1 dotted with the normal vector over the magnitude of the normal vector. Now, if you think about it, the magnitude of P naught r, that's exactly the distance that we're looking for in this question. So we have a formula for that distance. It's equal to the vector P naught P1 dotted with the vector n all over the magnitude of vector n. Okay, that's cool. So there's our formula. Now we're going to use the component method of the dot product. The dot product of P naught P1 dotted with n will be x1 x naught, comma, y1 y naught dotted with AB. Well, that's going to equal A times x1 minus x naught plus b times y1 minus y0, which is what's written here with a and b distributed into their respective quantities that they're multiplying, all over the magnitude of AB, which is just the square root of a squared plus b squared. Now we're just going to rearrange that numerator a little bit. We're going to say negative ax naught minus by naught plus ax1 plus by1, all over the square root of a squared plus b squared. Okay, now interestingly about this little part at the end here, this ax1 plus by1, let's focus our attention there just for a moment. Recall that the point x1, y1 is on the line ax1 plus by1 plus c equals 0. So if we just move that c value over to the other side, we get ax1 plus by1 equals negative c. So we can rewrite this numerator as negative ax naught minus by naught minus c, all over square root of a squared plus b squared. Okay? So that's the distance. Now, we can restate that, just factor a negative 1 from the numerator, and we have negative 1 times ax naught plus by naught plus c, all over the square root of a squared plus b squared. But distances are always non-negative. So the denominator will always be positive, but the numerator as written could be positive or negative. So we're going to use an absolute value to indicate magnitude. And so we're going to get the magnitude of that quantity. Well, the magnitude of that quantity, we can actually take that negative 1 out. If the inside is negative, or if the inside of the absolute value in that in that fraction on the up top left there, if the right here is what I'm referring to, this the interior of that absolute value, whether that be positive or negative, we can take that negative sign out since it's part of an absolute value, and we can say that this is our formula. And so we have a formula for the distance from a point to a line in R2.